Hi guys, this is Kishore and welcome back to Kishorelytics. In this video, I will be talking something really useful if you are working with data in Python. So that's NumPy. NumPy is an amazing open source library so that you can able to work with numbers super easy, fast, efficiently. So basically NumPy works with arrays. That's basically called the Python list. So if you are questioning why we are having a Python list, so why we want to go getting into the NumPy array means, so NumPy it will be overtaking by performance, convenience, and efficient manner. So grab your coffee, open your code editor, just follow my steps. So now after completing this tutorial, you are the hero to the NumPy. So sit back and relax. Let's get in the video. In this video, we are going to dive into exciting things that is called the NumPy. What's mean the NumPy? NumPy is nothing about the numerical Python. Imagine you have a toy box filled with the numbers. You want to count them, add them, multiply them, or play them with different ways, right? So NumPy is a super fast calculator for your number toy box. So I just come with an interesting story. I just explain all of the things and like you are a small child and I just explain all of the things like with playing toys and building stuffs, right? So all of the things are successfully completed. For I just written all of this code. I just written all of the plan, all of the content in an hierarchy manner. So don't worry about that. Just follow my steps. I just follow cover everything from scratch. The prerequisite for this NumPy class is that you know the basic Python right? That is enough for this course. So in this course, we are diving into the 0 to hero in NumPy. So just cover all of the things from scratch to advanced like masking, broadcasting, vectorizations, everything I just cover in this tutorial. So this tutorial may take while. So grab your coffee, open out a code editor, just follow my steps. So let's dive into it. So what's meaning the NumPy? I just come with an interesting story, guys. So imagine you have a toy box that will be filled with the numbers. Yeah, inside the toy box you can have any numbers like 1 2 3. It will fill with the numbers. So you want to count how many what are the numbers are in the time box, and you want to add them, count them, add them, multiply them. So find the maximum between them, find the minimum between the numbers, like or play with the numbers within different ways. So NumPy is a super fast calculator. It's also a calculator. NumPy is nothing but a numerical Python. So we are shrinking it to the NumPy. Numerical Python is very large, so they are shrinking it to using the NumPy. So NumPy is a super fast calculator for your number type box. So it's for numbers. You can create a multi-dimensional array. Later we are exploring all of the stuff. So now it's a super fast calculator for a number type box. It helps Python handles lot of numbers quickly and do mathematical operations easily. So what I'm going to do that. So first of all, we have list. So why we want to go for the NumPy list? So already it's have a list. We can have create the multiple dimensional list. Why we want to go to the NumPy list means, yeah, later I have prepared some content, but for now I just tell about NumPy is that. So it's for time consuming. We can do lot of mathematical operations in the arrays. So later we are discussing about all of the stuff. For now, it's a super fast calculator for the mathematical number type 2. So it tells Python add a lot of numbers and quickly do mathematical operations easily. So it is especially good for handling arrays. So I just told right, it's good for handling the arrays, multi-dimensional arrays. You can create a one-dimensional array, two-dimensional array, three-dimensional array, many things. It is especially good at the handling arrays like rows and columns of numbers. It's like in your pandas. In the previous video we discussed. In the previous video we discussed about the pandas. It's like a Excel sheet. So it is a mini Excel sheet, but much faster. So that's like in previous video we are discussing about the pandas. So in this video we are going to dive into the NumPy. It's a mini Excel sheet. Pandas is the Excel sheet. So that's it. So why we want to use the NumPy? So why we want to use the NumPy? It is faster than that. The first point is that it's faster than the regular Python list. So I just written all of this code. So you just follow my steps, right? I just written the handwritten notes. It's my handwritten notes. If you want these notes, that is available in the description box, or ping me a mail. So if you ping me a mail, I am happy to share all of the notes. It is faster than the regular Python list. It is faster than the regular Python list. It is very fast. It's very more faster. I just told the time accuracy also in the later videos. So it is good for the math, science, and machine learning. Why we want to go to the mathematical NumPy means it is very who are using NumPy. It's used for the mathematical scientists and machine learning enthusiasts and data scientists, data analysts. All are used. Who are all working with the data. Who are all working manage the data. Who are all operate with the data with like converting the mean, median, converting all of those stuffs. They can use the NumPy. It's let you to operate on the whole groups of numbers in one go. You can cover everything. You can cover in a single line of the code. You can do multiple operations to over all of the data. Too. It can be maybe 1 million, maybe the 2 million of data. You can write 1 million NP dot minimum of median. Anything you can create in a single line of the code. You can analyze everything. Right? That's main intuitions. So here is a simple example. I just told the simple example. I just cover all of these things in the later things. Now it's for the simple examples for you. So what I'm going to do, first of all, let me open the Jupyter notebook that is available in my Chrome browser. You write a Jupyter notebook in your command terminal. If you are already installed the Python, then only you can able to use the Jupyter notebook. So it's a simple example. Later I just covered all of the things, how to install it, how to install from scratch, how to install to vectorization, broadcasting, masking, everything I covered. So now I just covered for this. I just copy this code. So I just already work with the code. So if I run this code, please wait for a few seconds. It will be running. So we are using the import. We are using the type box is in my toy. I just want to use the NumPy. So I want to import the NumPy. So I just importing from Python. I'm just importing the NumPy as NP. So we are giving the name for the NumPy. NumPy is NP, right? So in pandas we are giving the PD. In Seaborn we are giving the SNS, and in Matplotlib we are use the PLT. So we are giving the limplay, and in Streamlit we are giving the ST, may have the name SLT. So it depends on the per person score using the NumPy things. So I'm just creating a single list. If you, it's a basic beginner thing to creating a list. I just cover all of the things in the beginner tutorial itself. I think this is in the second tutorial. So my list is equal to 1 to 3. I just creating a simple list. So I just converting this list into the NumPy array. So I just converting this list into the NumPy array. How we can able to convert? Yeah, that's available inbuilt with the NumPy. Array is equal to np dot array of array np dot NumPy array. I am just giving np dot array of my list. So then our list will be converted into the NumPy array. So we are converting, right? So I just printing print my array of, I am just printing the array. So again I'm just printing each number in the items 2. So I'm just giving array is equal to this NumPy array is equal to star 2. Okay. So I just told with another example also. So print yeah, it's my NumPy, my list, right? So I'm just giving, it's not available. It's available. If I give like this, I just want to show. So see, if I give normal list star 2, if I give normal list star 2, it will be replicated multiplied by 2. See, 1, 2, 3, 4. Again, it will be printing 1, 2, 3, 4. So when we work with the NumPy array, if I give a NumPy array star 2, it will be printing 1 star 2, 2, 2 star 2, 2, 4, 3 star 2, 6, 4 star 2, 8. It will be doing operation in that array. So we can, everything is different, right? So in this array, we are planning just, I just planned this example in the later sessions. Now for this sessions, I just explain in this code. So in this array, in normal array, it will be duplicating again and again. It will be printing. In NumPy array, here it will be converting into 2, 4, 6, 8. So how will be working, right? This is pretty good, right? And we are using the NumPy array. We can able to do much of the things with the data. So that's I think. I just covered I just want to cover these things in later. So I just explain all of the things for explaining. So now I just want to show to you advanced practical examples. So I just copy this code. So why I'm copying this code means it's already 2 hours course. So if I write this code again, I just made some mistakes. I just want to debug the code. I just want to correct the code, and I just want to explain this code. So I just if I write the code in the beginning, so you can able to, I just explain all of the things. I don't leave single line also, right? So I just want to write from the beginning means it takes much time to create. So I just explain all of the things and without leaving a single line. I just explain all of the things until you understand. I just explain all of the things. So I'm just using NumPy. So I'm just importing the NumPy as NP. This line also again and again I'm repeating. So why? I just want to explain all of things without leaving a single line. This is my basic intuition for Kishorelytics. So import NumPy as NP. I'm just importing NumPy and is giving the nickname as NP. So if I give the creating the list, if this is the multi-dimensional list, so don't worry about that. We are covering 3-dimensional, 4-dimensional, multi-dimensional list in the later. So temps is equal to np dot arrays of, here I'm just giving, opening the parentheses, inside this parenthesis I'm just giving the square bracket. So I am just giving the square bracket, it's a set of list. So I'm just giving a set of list. So I'm just opening in the parenthesis, I'm just again I'm opening a square bracket, I'm just giving some of the list. So it's a 5-dimensional array, I'm just giving a 5-dimensional list. So again, I just want to print the average temp is equal to np dot means of temps. In this temperature, axis is equal to 1. Axis is equal to 1 in the previous video itself. I just told about the axis is equal to 1 means it's a column. So it will check all of the columns. It will going to all of the columns and find the means 30, 32, 31, 28, 27, 26. It will find the mean means average. Average means sum of all things divided by total number of things. So it will be using finding the means of this column and it will be written to store in the NumPy array. So again, it will find for 5 columns and it will be printing the first of all I just run this code, after I will explain. So for this 29, for first line 29, for the second line second list is will be 23.71.42.585 something number, and third list it will be 23 and fourth list will be 18 and fifth list will be something if the number will not be available. And I just want to find the maximum of those numbers. So I just want to find the maximum of those numbers, means print max temperature of this week is equal to np dot max of temps. If I give this means the 40 will be available here. This only will be the largest number in the temperature. So just it will be printing. So see how pretty the NumPy is this. We are creating multi-dimensional array. We are working with the multi-dimensional array with a single line of the code. So we np dot means if we give axis equal to 1 means it will be goes line by line. So it will create a multi-dimensional array using within a single lines of the code. We can able to find them average. So that's the basic intuition of this. So I just cover. So I just want to recap the sessions what I have taught before. So what I have taught means NumPy faster number playground for first number playground for Python. It's a simple calculator, super fast calculator. The interviewer asked about the what is mean the NumPy means. So you want to explain all of the things. NumPy, you can able to explain with the if you explain with the numbers, if you explain with the examples, means the interviewer get good impression on you. If an interviewer gets a good impression, you can able to get selected in the company. So as I just explained all of the things in this later sessions. So NumPy is equal to fast number playground. So now it's a fast number playground for Python. It's for Python. If you give the np dot number small, you can able to create a smart list. It's array. We can able to create the smart list, right? So it must faster than the the third point is that it's much smarter than the and easier than the regular list for mathematics. We can able to create a multi-mode mathematical Python. So it's mainly used in the AI, ML, machine learning, artificial intelligence, statistics, and data science and science projects also. We can able to use the NumPy also. So the most important thing for the used in the NumPy is machine learning, data scientist, and machine learning engineer, artificial and Gen AI. If you want to create the multiple models, you want to analyze the data, right? First is EDA. So if you analyze the data, then only we can able to create the models. So that's the basic intuition of this. So yeah, these are the things we are covered in this sessions. So the next topic is the difference between the arrays and the Python list. I just told right in the previous section itself. I just told what are the things I want to cover. I just planned 2000 lines. As now we are coming in the 86 line only. So difference between the NumPy and the arrays. So theory. First of all, we want to give the theory knowledge. Few interviewers has most of the interviewers has covered theory knowledge. So we have already crossed the practical knowledge in the practical session. That I also cover the practical knowledge also. So in the theory knowledge, baby style explanation. Imagine the Python list is like a regular backbook. Yeah, I just want to again come with an interesting story. So imagine this. My style of teaching is that sketching the concepts or explaining the things like you are thinking you are a baby, right? Baby style explanation. And my style is that like this only. If I explain, if a baby understands the concepts, what the concepts I'm teaching, so definitely the adult can be able to understand the concepts. So that's why I'm teaching the baby style explanations. Imagine a Python list is like a regular backpack. Yeah, in a school days, in a college days, you can able to get the backpack, right. So that's the basic information. It's a Python list is like a regular backpack. You can able to put the toys, books, foods, or anything in it, right? Numbers, words, ever, etc. So in the Python list, we can able to, it's a collection of arrays, right? We can able to put it's not only a single integer. If it doesn't give us any restrictions, right? It will put the, if you want to put only the integer, if you want to only put the list strings, yeah, that's also we can able to put the integer, string, integer, float type, anything you can able to put. You can able to put the toys, books, foods, or anything. So NumPy is that like a math box, mathematical box only. It only holds the numbers, and it's made for speed and cool mathematical tricks. It's like a math box. It's only give only old numbers, not strings. If you put the strings, it shows an error. So that's why basic condition. The NumPy arrays is like a metal math box. You can, if it only holds numbers, it doesn't hold any strings. So that's the basic conditions. So I just want to give the main differences in the tabular column. So if I give the tabular column to you, you can able to write in your notebook. And if you when the interview or any drives or arrive into the campus or any talk, so you can able to revise it. So just yeah, it's already in the second standard, third standard. You can able to remember, right? Python list which is NumPy list. That's a basic condition. So yeah, it can hold different types. Yes, Python list can hold different types. It can be an integer, strings. Yeah, it can be anything. It can hold anything. So can NumPy array hold different types of data? No, it only holds numbers. So the basic condition. So wait a minute, the camera angle has been changed. I think so. Okay, fine. I think correct, right? Is I visible? Okay, fine. So its speed, the speed for the Python list is slower and the speed for the NumPy array is faster. So the mathematical operation, we can able to only the manual look to the list, right? So in the NumPy array, we can able to built in automatic functions. There are a lot of functions in the NumPy. We can able to use the NumPy and we can able to create that in the manual and the automatic way. So in the memory efficiency, it is if is a NumPy Python list is memory efficient means I just the answer is no. If a Python list is a very normal, no, it's not memory efficiently. But NumPy is very well in the memory efficient. So is that used for mathematical and ML's machine learning techniques? No, it's not really. They are used for the mathematical learning, but often they are used. So sometimes. So but the NumPy very useful in many of the things. So I just cover all of the things in the previous session itself. So yeah, I just want to show the time to the difference between the list and NumPy, right? So if I give the examples, you can able to how faster you can able to create a better impression on the NumPy. So first of all, these are the basic examples I just covered in the previous example itself, the simple example itself. I just want to importing the NumPy as NP and just using my list is equal to 1, 2, 3, 4. So I just I'm converting the NumPy my list into the my array np dot array of 1, 2, 3, 4. So print, I just using print list star 2. I just using these lines and just if I print this means it will print 1, 2, 3, 1, 2, 3, 4. I just explained in the previous section, right? So and array star 2 is means my array star 2 it means it will print 2, 4, 6, 8. I just explained and show the output in the previous uh, just a few minutes ago, right? If you don't watch it carefully, please make sure to rewind this video. So this is the best example I have created this for the NumPy, right? So first of all, I just copy this code and just entering into my Jupyter notebook. I just place this code. So I just want to create. Yeah, it's okay for you guys, right? So first of all, I'm just using the NumPy import NumPy. First of all, I'm just run this code. So yeah, the code is only visible for me. So I just want to run this cell, right? Yeah. Say import, we are importing using the NumPy as NP. We are using that time also for the time efficient, which is time efficient. I just want to show to you guys. You don't believe Python list is better, why NumPy is, I just want to show with proofs. So I just give import time. So I'm using the time model. You can able to use the time model also. So I just want a big list. So I'm just creating the big list. Pi list is equal to list of range of turn. It may be a 10 lakh, I think so. Yeah, 10 lakh. So I'm just creating a NumPy also. I'm just converting this pi list into the NumPy list. Okay. So I just want to create start is equal to time dot time. So time dot time, and what my time, I'm just starting 10:59. So I'm just starting time dot time, and the pi result is equal to x dot 2 for, it will be doubling for in Python list. So end is equal to pi time dot time. So what are the time? In the time that will be ending. So we are printing the same n minus dot. So it will be taking 0.52 minutes. So when we use with like this with NumPy, it will be creating what the time I'm starting, what the time I'm ending, it will be doubling. So it will takes 0.52 seconds, but the NumPy takes 0.00. These is my proofs. I just showed right why the NumPy is best in case of, instead of this, right, 0.52 in 0.0. That's a basic illusion. I just want to tell to you. So that's a basic illusion. I just covered each approximative value. This in the about time I just covered when I tried this code in my Jupyter notebook in the morning. I just covered 0.12. In the NumPy time I just covered in 0.01 seconds. Right. So for this recap, using the list I just covered, like it will be list is only for, we can able to win the within the list, we can able to create the numbers, names, and it's like a normal school backpack. You can able to carry everything. But in the NumPy, so in the NumPy, it will be carrying only the numbers, right? So NumPy is better for the data analysis, machine learning, scientific. Again and again, I am just repeating these things. Why? It will be fixed in your mind. That's why I am just inputting. So these are the things I just covered. I just covered two sections in the single session itself. I just covered covering the third session also. So I just want to install the Python. So installing the NumPy. If you want to install the NumPy, right? So it takes, yeah, it takes average 5 minutes to install. Okay, fine. So what is installation? Imagine you want to play with the new toy, but the toy is in your house set. It's not in your house set. So installing NumPy, bringing the toy home, getting into the Python, getting it into the Python. So I just want to tell, open your terminal. So just follow my commands, open your terminal, pip install NumPy. If I put this code, if you are using a NumPy, go to NumPy, so get NumPy from the internet and put it on my computer. That's then if I want to put you play with the new toy, but the toy is in my shop, means how I want to play with the text, right? So I just want to get to my toy to my phone, and then I will be playing with the toy. So that's the basic intuition. So just want to install a NumPy, go get through the internet, goes up to the internet and search for the NumPy and install in my PC. That's the basic intuition. So I just copy this code. If I run this code, I just already installed the NumPy. If you are beginner, if you are the if you are installment, that takes some times to install. If in my screen it will be showing requirements already certified, because I already written this code, right? So that's the basic intention. Wait for a few minutes, it will take some time. Yeah, the requirements I just already told, right? Requirements already satisfied. It's available for me. That's the basic intention. If you are beginner, it will take some time, and it will be downloaded on your PC. I just delete this code, okay, for need purpose. So if you are using the Jupyter notebook, you can able to use this command exclamatory symbol pip install numpy. Then ask tells your notebook to run it like a command. Okay, that's a basic instruction. This also you can able to numpy. And how to import the numpy? Yeah, just repeating a lot of things. Import numpy. You can able to give numpy. Most people use a shortcut, right? Import numpy as np. I just giving the numpy for shortcut for the numpy and just giving a nickname for the numpy. So I just giving. So these are simple examples. So if we use after you downloading it, after downloading the NumPy, you can able to put this means the version now the for up to recording for this video, the version of this is 2.2.4. When you see in the video, if in the version may be changed anything, I just don't know. The vision may be changed. The vision may the scientists get research again and again. The researchers and PhD graduates research again and again and updating the number also. It's maybe that depends on the things when you are watching this video. So I just want to if you are getting an error, if you are getting a that's also I'm just that every users can make. Model not found means the NumPy is not installed. Run pip install NumPy. So NumPy is not installed. Model not found means if you are using the input but model error found, model not found error means you want to install the NumPy. Please make sure to install the NumPy. So I just covered all the things. Import error means you just type the import from. These are the common mistakes, but I will also make this mistake. Practice makes the man right, correct, right. So recap. I just want to give the stack pans to you. I just covered in these sessions. I just covered installations. I just want to import the toy from my import. Open the toy box, importing the NumPy. You must install the once, but import every time. You must. Yeah, this is also an important thing. You must import the install the thing once, right? Importing the installing the NumPy is once, but you are importing again and again. It's a basic intuition. So in the next session, we are just covering the water dimensions there. In the later sessions, we are covering from scratch to advanced. As cover the I just put the dot in your notebook. Right. Later we are drawing a line to on NumPy. So I just covered subscribe to the Kishorelytics and stay hydrated. Grab a coffee, have some notes, have some snacks. Also stay hydrated. Right. Then only you can able to study the NumPy course well and good. So let's get into the second sessions. Yes, guys. For our next section is dimension and shapes. So have you guys ever watched the 3D movies, right? So that's a basic indication for that's a basic thing. So if you are here about the 1D, 2D, 3D, that means that's good for this about knowing the sessions. So imagine you have a box of toys. So one time means it's a 1D. If I have the two row of two top two boxes means it's 2D. A stock of row means it's a 3D, right? That's a basic intuition. In that's a basically if there is a one tie, it's a 1D. If a row of toy boxes, it's a 2D. A stack of row means it's 3D, right? In NumPy, the dimensions tells you how deep the boxes go, right? So if you can able to create the single list, you can able to create the 2D dimensional list. You can able to create the 3 dimensional list also. So that's a basic condition. In NumPy, dimensions tells you how deep the toys boxes go. Shapes tells you the sizes of each layer of the box. The shapes, that's the shape tells you which layer of the box. The size of the box. The shape doesn't give the shape. It gives the size of the box, each layer that the box go. So that's a basic intuition. So what is the dimension? What is the dimension? So dimension is also called the axis. It is how many levels of your data has. It has how many of your level data has, guys. First of all, if you have a single row, it will create the 1D array. If you have the two list, if you have a table, if you contain the 2 dimensional list, it's a table, right? A row of stack means it's a cube. Cube means if you have the 2 dimensional, see here, I just have the 1 dimensional 1, 2, 3. So here I just have the 1, 2. Here just having a 3, 4. So that's a basic condition, a table. So here I just having the inside this I just having the 2 list. So first of all, I just opening this square brackets and again I am opening this with one list. It's a 3D list, right? So I just want to cube. It's a cube of numbers. So first of all, dimension also say it's also called the axis. It's how many levels of your data as it tells how many of your level data assets. If you are creating this 1, 2, 3. For creating a 2 dimensional list, you want to give the square brackets inside this. You can able to give the setup list. So in 3 dimensional array, it's a cube. It's like a cube. You want to put the for this you can able to add the first square bracket inside the for each setup list you can have a separate square bracket. That's basic condition. So you can use the n.nim np.n.ndim to see how many dimension it has. You can able to see. So it's also it's going to cover in the later sessions. So first of all, let's get dive into the shape. So shape types tells how big the data each layer is. So how big the data is. So shape tells it will shows that how many rows. It shows how many columns in your data. It's like a table. It's like a rows and columns. I just tell right. It shows how many rows. It shows how many columns in your data. So shape means so if you have a 1D race, if it has 3 items means it will show the 3. 1D with 3 items. If the shape is if the NumPy output has been 2 comma 3 means it has 2 rows and 3 columns. It's a 2D. So if the shape gives the output as the 2 comma 2 comma 2 means it's 3D cube, 2 blocks each with 2 into 2 data. So this is the basic condition. There is here 2. So where is my mouse point? I just want to cover. So 2 cross 2. It has 2 blocks. See, it has 2 blocks. So each block contains 2 cross 2 data. So that's the basic condition. You can use the here you can use the shape to find out the name. It is a very important function when you are working with data. Means if you want to see the how many columns and how many rows in your data, means you can able to see the shape. This shape can be covered in pandas also. That's a basic condition. I just want to revise the pandas as well as the NumPy, and I want to revise gaining the knowledge and revising the knowledge. It gives a better thing, right? That's the basic condition. You can able to use that in dot shape to find out the shape. So for this, I just want to cover some examples, right? So let me. Why my pad is not working? So I just want to go to this. Into this. So let's put here. See, I just create the simple array np.array of 10, 20, 30. I just covered simple array. It's a print 1D array. It will print the array 1. If you print dimension 1, if you want to see how many dimension, it will maybe the 1 dimension, maybe the 2 dimension, maybe the 3 dimension. I don't know, right? If you are a beginner, if you can know about dimensions, right? If you want to see the dimensions, how many dimensions is this? Means array.ndim. If you use array1.ndim means you can able to see it's a one dimensional array. If you want to see the shape means you can able to array.1.shape. That's the basic condition. So it's a 2D. For 2D example, you can able to see that it's a 2D array. It's a 2D array. You can able to see a dimension equal to 2, and in the shape between them is 2 comma 3. I just explain all of the things. Np.array means first of all you want to give the square brackets parenthesis. Inside this you want to open the square bracket. Inside this you can able to add a set of list. So that's the basic intuition. So I just want to cover the third 3D examples also. Array3 is equal to np.array of opening this parenthesis. Inside this I want to again open the square bracket, right? Square bracket, and inside this I just having a set of blocks 2 cross 2 data. Inside this I having that, right? So the output for this is 3D. The dimension is 3D. Inside this I having the 2 comma 2 comma 2. That's the basic intuition I just want to cover. So I just giving the summarize to these concepts, right? So you can, if you use the n.dim, you can, it can tell how many dimensions the data has. If you use the array.ndim, it will add the 2 dimensions. It will use the shape. If you use the dot shape means it will give the how many shapes are in the data. So it may, the first column is to maybe the rows, and second column the second number it means the tool. It has the rows and columns, right? That's the basic condition. 1D means a line of numbers, 2D means a tables, 3D means a collection of multiple times. It's a cube. It's like you can able to think it that it's a cube. So next topic is that how to create the NumPy arrays. So that's the basic condition. If without creating the NumPy arrays, how we can able to create the we can able to work with the data, how we can able to learn the NumPy, right? So that's the basic condition. Creating the NumPy arrays. Think of NumPy array is a smart list. I just explained this in the first session itself. Think of NumPy array is like a smart list. You can able to create it. So, but it's a faster, stronger, and better at math. We can able to create a better math at NumPy than a regular Python list. In Python list, the time consumption is very high, and we can able to create a single list only. Yeah, definitely we can able to create the multiple list, but we can able to manually loop through the data. But we don't want to do manually loop through the data, but if you want to do the automatic means you can able to use the NumPy. So that's only we are able. That's only we are getting advanced like NumPy. So we are using NumPy. How to create the NumPy arrays? So the basic way. So how to create the NumPy? We are importing the NumPy as NP, and I am using the array is equal to np.array. Inside this is giving the 1, 2, 3, 4. So I hope everything is covered. So in this print, I just giving the print. So if I give np, if I just using np.array means it will be automatically converted into the NumPy array. So this is called the 1D array, just like a line of numbers. If you use for the 2D array means it will be used for array 1. The only array means np dot array is equal to 10, 20, 30. So inside the square bracket, you want to give what are the numbers 10, 20, 30. I'm just giving you will print the array 1. So for 2D array, so I'm just giving the np dot array of inside this inside the param bracket. I'm just using the again I'm just using opening the square bracket, and again I'm just using the square bracket. So that I'm just using a setup list. It's a setup list print array. Like 3D means it's like a cube. Our array 3 is equal to np dot array of square bracket inside this just like a cube. You can if I just explain all of things iron and iron, so you can able to remember. So some special array you can able to create means you can able to create np dot 0 ones. If you in the np dot zeros means the arrays will fill with zeros. There is no value in this the array. If you give the np dot, so I just want to explain these things, right? So just copy this code. So I just plan all of this code in the that station. So I just want to explain to you. So and maybe I'm named by this indeed variable. So just if I give see the values are filled with zeros, right? That's a basic condition. If you want to fill, if you don't have any logic in your mind, if you want to perform any other operations, like when we multiply, when we add with something 0, we can able to get the same numbers. Means you can, if you want to use any logic, you can, if you want to use zeros as a logic, you can able to use this, right? So that's a basic condition. I just covered. NP dot means the array is filled with ones, like zeros, like ones. NP dot full means you can fill it with any numbers you want. So if we give this plan, so where are my? So I just written this code, right? I hope yeah. So if we give np dot full means all sevens, np dot full of 7 comma 7. So I want to show to you my fellow subscribers. I don't want to explain this code. I just want to show the output also. So that only you are able to see my channel. So only you are seeing my channel. So if I give again the b, if you give the means there is a 2 rows and 2 columns. In this full in the entire list, if you want to see the 7 means you can able to use the 7. So this is a basic condition. There are many functions are available in the NumPy. You can able to surf in the internet. If I want to see this in the NumPy documentation, you can get everything, right? So identify matrix. You can if you once np dot I means if you want in one in that diagonal. If you want to means you can able to create the np dot array means. So I just want to create all of show all of the things, right? As I'm naming it a variable as c. Inside this I just want to give that np dot I is equal to 3. So if I give c again, you can able to see the diagonal one is filled with the diagonal is filled with ones. That's the basic intuition. So again, I just want like range. If you see the range for I in range of it, if you see much better, like range, it's much better, right? So I just want to see. So first of all, I just copy this code for timing and swimming purpose only as copying code. But you are not doing this course again. So I'm just giving the D. End. I'm just printing the end means you see the print means 1 10 and 2. It means I just want 1 to 10 inside this. I just for skipping, it's like a skipping odd numbers, printing odd numbers, right? 1 3 5 7. That's a basic loop of numbers. So linspace means evenly spaced numbers between the 2 points. So random np dot random means yeah, I just want to show the output also. So np dot linspace means if you give the minus 5 values to 0 to 1, if you give np dot linspace 0 comma 1 comma 5. So I want 0 to 1. Inside this I want to create the random numbers. So inside this where are the points we can able to create. The output is 0 0.5 0.5 0.25 0.5 0.75 1. So inside this range you want to create 5 numbers. You can able to create this you can able to use that linspace. So np dot random means you can able to randomly float numbers. You can able to create the random numbers. You can able to play with the numbers. So if you don't want to have any numbers in your mind, but you want to create the numbers list means you can able to use the random. So it's a basic condition. So using the np dot random dot rand, you can able to get the random numbers. So np dot random dot rand of 2 comma 2 means you can able to create them 2 comma 2 2D array. That's the basic condition. If you want the integer means random integer means you can use the np dot random dot rand int. You can able to create the random integers. So np dot random dot rand int 1 comma 100 comma 2 comma 2. I just want to show this example. to my subscribe. It's very difficult subscribe. So inside this I just giving the E. Inside this I just keep on this. See, inside this 1 to 100. I just found the 2 comma 2 try. It will be printing random numbers. If I run this code again, it will be changing randomly changing. Now the output is 972. If I run again this code, if you see the 1768, I just want 2D array inside this from 1 comma 100. Inside this 1 comma 100, I just want to see that 2D array. Whatever it may be the numbers, just don't have any numbers in my math, but I want to create an array means you can use the random. This is the basic intuition. So the summary is that np.array you can able to create a mode from a list, you can able to create the array. NumPy array, that's the basic intuition. So np.0 means np.1, np.full. I just explained all of the things in the sessions. np.0 means if you want to fill with zeros, you can able to create this. So wait a minute. Wait for a minute. So np.1 means np.1 means you can able to create all the numbers filled with ones. np.full means all full with what the number you wanted means you can able to use the np.full. np.arange means it's a range. It's a range. np.arange. Yeah, you can able to create the range between them. np.linspace means you can able to create them, make smarter number lines, and you can able to create. You don't have any currently you don't have any numbers in your mind, but you want to create number in list, you can able to create the np.random.rand. So np, if you want the integer, you can able to use the np.random.rand. That's a basic intuition. So the next topic is that what are the random arrays. So random arrays, again I just want to explain the random arrays in detail, right? So it is a very important topic because many of the things, many of the companies, if you don't have to work with the data before the training, it's in the training period. If you want to work with the training period, you can able to create the number which is random, right? So that's a basic introduction I just want to cover. Random arrays are like sharing a magic dice. Yeah, I just want to tell you a small story. Have you guys ever seen a dice? If you see the dice once, it will be throwing an answer as 1. If you guys again throw a dice 2, it will shows another answer. Part of it may be similar to first answer, it may be similar to the second answer. Again and again, if you throw again and again, it will go giving the again some numbers differently. Right? That's the basic condition. Random numbers are num arrays like shaking a magic dice. If you shake the magic dice once, it will give you the numbers. If we run this code again, it will give you another number. That's the basic condition. You don't decide the numbers. NumPy suppresses with your random numbers. You don't decide the numbers. It will decide NumPy suppresses with the random numbers. You can say, hey NumPy, give me a box of numbers that are totally random. If you tell this code right, if you do the NumPy means it will give the random numbers. That's the basic condition. Why we can use the random numbers to test code? Yeah, I just told right, to test code or algorithms. So to simulate the data, to build the machine learning models, a very important topic. Please make sure note of it, because if you working with the machine learning models, we want to definitely know the NumPy. So that's the basic intention to build the machine learning models for fun, choice, and experiments. So that's the basic intention. If you want to create fun, if you want to create the machine learning models, many other things, if you want to means, you can able to use the NumPy. So I just these are the NumPy random techniques, random arrays in NumPy. I just written this code. Just say for means. I just want to explain all of this code in my Jupyter notebook also. For now, it's a 3 sessions, right? I just explain all of this code. I just again and again, I just explain what are the important things. I just explain in my Jupyter notebook. For now, I just explain in my notepad itself, right? Yeah, it's very good. So if you want to create the random numbers, if you give the np.random.rand functions, it will be giving the random float numbers between zeros and ones. So it will be giving rand functions when it will be giving the zeros and one, but it will be the float numbers. np dot, so wait for a minute, np dot random dot 2 comma n. Okay, for this I just want to create the numpy means, yeah, you definitely you can able to create. So yeah, again I just want to again, if you print the a means it will be print, it will be the ranging between the 0 to 1. It will be not more than the 0.1, it will be not less than the 0. So 1, it will be not more than the 1. So that's a basic intuition. So if we get the random float numbers between the 0 and 1, that's the basic condition. If you give the np.random.random, it will be randomly float. It will generate the random float numbers, but the mean is 0, standard deviation is 1. So the basic condition. So both are similar, but it will be create the float numbers. Both are creating the float numbers only, but it will be numbers between the 0 and 1. It will, the mean will be the 0 and the standard deviation will be the 1. So when I am taking the statistics, when I am taking this, so that time you can able to understand what is mean the standard deviation, mean, average, right? So that's the basic condition. So np.random.random means random integers in a range. So it's creating a random integers. Here, if you want random integer means you can able to give the random integers. So it will create the random integers in a range. np.random.randint dot 1 comma 10. I just want inside this range between the 1 comma 100. I just want to create a 2D list. So this list I can create in the previous session itself, right? So I just want to create the np.random.random. It will be same as the rand function, that but as a different style. I just want to show to you. So just writing this code again, or I simply copy this code, right? So for time consuming purpose only, I just copy this code. If you are a beginner, please make sure to read this code by your hand only. Don't copy the code. So this I just want to create the B as same I am just creating. If I put B, see, you can able to create the random numbers. It will be creating the same, the random functions only. Okay, you can able to see the random string. If you run the again, it will create the random codes. Random np.random.choice means randomly picks from a list. If you have certain list, if you have certain numbers in your mind, but you want to create, right, np.choice random choice 10 20 30 means you want to create the randomly choice means you can able to get the np 10 20 random choice means it will create 10 at one time, it will create 20 at one time, it will give 30 at one time. That's the basic condition. It will, whatever it may be, it will first of all you give 20 but then 20, that what I will be randomly generating, right? NumPy suppressing using the random list, random toys, right? So this is a very important point. np.random.seed controls the randomness. We can able to control the randomness also, make it repeated. If you give that, most of the machine learning models use this code. So please make sure to understand this code. If I print this and again I'm printing this, so what happened to this? So wait 5 minutes. My drivers are getting failed. So again I want to check my Jupyter notebook. Again it gets default. Okay, I'm damn sure that doesn't make in the next video, next session, next video. So it will be, we can able to create the numbers randomness. We can able to control the randomness. When I run this code, it became same got the same output. You can also get the same output. It's create a seed. We can able to create the randomness also. And that's the basic intuition of this. So I just want to give you the practical examples also. You can able to work with it, right? I just explained these things in my Jupyter notebook also. So first, I'm just revising this code. Random np.random.random means you can able to create the float numbers between the zeros and ones. We can able to create this, right? Shape 2 rows and 3 columns. That's a basic condition. So np.random means you can able to create the random numbers from the normal distribution. Normal distribution means it's a curve. So if you know the statistics, you can able to do it. But don't worry about make sure Kishorelytics subscribers. Just creating the another separate tutorial, separate course for statistics also. So array is equal to np.random.random of 2 comma 3. That's the basic intuition. So if you want the integer numbers, you can able to create the np.random.randint. If you give means np random numbers. If you want the random numbers same as rand, we can but a different syntax. So but as a different syntax, we can able to create the random np.random.random. You can able to create the random numbers also. So if you give, we can able to control the randomness also. np.random.seed of 0 means you can able to get the some output. So this same output will have in the your PC also. If you run this random np.random.seed of 0, if you run the same code, if you, I have some code, right, my PC doesn't stuck. If I have some same this code, if you want to see this, say np, if you put the np.random.seed of 0, you can also get able to get the same output. That's the basic intuition. So you can able to random that you can able to use random with custom rules. Yeah, it's advanced sessions also. Yeah, random floats between the I just want to create the random numbers floats between them 10 and 20. You can able to create the one command. I just told, right, one command. Yeah, you can able to create like this also, but it's the advanced method. I just doing all of the things. What are the possibilities that can be able to create? Arrays is equal to 10 plus 20 minus 10 star. If I 10 20 minus 10 means it's 10. So first of all, the 10 will be multiplied. First of all, it will be multiplied with this number bracket of board mass. Do you know about the bad mass rule? Right, that's a bad mass rule will be comes in this. First of all, bracket of division. So bracket, first priority is bracket. So 10 20 minus 10 is 10. So 10 is multiplied with random numbers, and then it will be adding with 10. So that's the basic condition. We can able to create the random normal distribution with custom mean and standard. So mean is 50. We can able to create the standard deviation is 50. If you give array is equal to mean and mean, we can able to create the array. So we can able to create the random normal distribution also. So don't worry now, no worry about that. If you want to know something about the normal distribution and random normal distribution, go search with the internet. So but now we don't worry about the normal distribution, it's covered in the later sessions. So summary is equal to snack time. So summary, I just want to give the snack times to you, right? Just creating another and again. So rand is equal to, we can able to create the random numbers from zeros and ones. So random means you can able to create the random numbers. Integer means you can able to randint. So choice means you can able to pick randomly from the list. So you are giving a, so you have certain choice, but you don't know what how to pick. You can able to. I just want to give the another examples also. For the choice, going to a movie, going with friends, going with family. These are the choice. If you give to the NumPy the certain list, it will be giving certain choice. Go with the family. So my choice is go with the family. So NumPy choice is different, right? That's a basic condition. So seed means it controls the randomness, like say a game. That's a basic condition. So I just want to cover the next topic in the next section, right? So okay, now I just covered. So NumPy data types. What's mean the NumPy data types and typecasting? In this same section itself, I just want to create the NumPy data types and typecasting also. So what is mean the data types? So for the subscribers for the Kishorelytics channel, from the beginning of the video, for the part one video itself, I just told it's like a sugar bars. Which type of the sugar? It's maybe the brown sugar, maybe the salt, whatever maybe it controls the sugar box, right? It will be showing tells what type of data you are putting into the sugar box. That's the basic condition. What is mean the variable? The variable is nothing but the sugar box, right? That's the basic condition. So what are the data type means? Imagine you have a toy box. Some toys are numbers. Some toys are numbers. It may be the integers, right? Some toys are words means it's just strings. Some toys are true false means it's in the boolean. NumPy wants to know exactly what kind of toy it's playing with. So that's what the data of type is. So I just want to NumPy wants to know. So NumPy wants to know what type of the data you are giving it's playing with. So it's only we are explaining sessions NumPy data types and typecasting. So why it doesn't matter, right? Why it matters? This data type is really important in the NumPy. Yes, it's definitely important because we can able to save the memory better, but we can able to give the mathematical running. So if you create the floating data types and integer data types, both the answers are different, but you use same result, accurate results. Not if you want the accurate results, if you give the means you can able to get the better results, right? If you give the float, if you give the float with the float means you can able to get accurate result. If you give the float num with the float means you can able to get another result. That's the basic condition. If you give the mathematical correctly means you can able to give the mathematical correctly. So if you use the float and data types correct means you can able to get the mathematical correctly. So we can able to speed up the code also. We can able to speed up of your code also. So a common data type that the NumPy can use is integer, float, boolean, string. That's a basic condition. Integer means 632 bit. It can be the example is 1, 50, 30, 32, 40, 40, any number. It's a 32 bit integer. You can able to get the float bit means in decimal. It's a 64 bit. You can able to get the 3.14, 3.14. That's many things. Integer you can able to get. So bool is nothing but the true or false. Strings is nothing but the apple, banana, cat, anything you can able to create with the NumPy. These are NumPy data types. Don't worry about that. I just cover all of the data types in the first session itself. What are the data types in Python? I just cover all of the things, right? So if you don't know about that, please make sure to watch that video. It's a part 1 video of the Python crash course. So you can check the type of your NumPy using this dtype. If you want to see data type means you can able to use the dtype function. But first, in the first session, I just explained with the dim ndim. Then for searching the dimensionality, for shaping the purpose, you can use the n.shape, np.shape. and you can able to use the zeros, np dot zeros, np dot ones, np dot fill, np dot size, np dot lanes, linspace, np dot arrange, and yeah, range, np dot arrange, and many of things it is covered in the sessions. Please make sure to note all the functions are in the different page and the concepts are in the different page. If you see the concept when the functions only, you can able to remember in the things when you are working with the machine learning models. That's the basic introduction. I just all of these steps also. So I just want to create. So yeah, I just covered this session, and later we are binding this session and continuing the sessions. So we are using the import NumPy and the NP, and this is creating the array. Array is equal to np dot array of 1, 2, 3. If you want to see this, yeah, definitely you can able to see. The output is 64. You can able to, if you're depending on the system. Yeah, for my system it's a 32-bit. If you see, it's a 64-bit system. You can able to see the hint 64. If you are using a 32-bit compiler, you can able to see the 32-bit. It depends on the systems, right? So typecasting. What's mean the typecasting? I just planned this typecasting in the next session, so don't worry about that. I just explain all things. So for now, typecasting is a type of type. We are converting. Casting means changing the type of the type. So we want to change the type of. So here now the toy is in the float. I just want the toy in the integer. So I just want to change the type from float to integer. I just want to change. So changing the type of the type is the typecasting. So I just want to tell to the NumPy, hey, change this float types to the integer types. That's a basic condition. Right? Arrays is equal to np.arrays of. So I just enter into my Jupyter notebook. So see, if I see np.array of 1.5, 2.3, new array is equal to np.as type of int. I just converting as type. We are converting float type into the integer array. So this converting as type is int. So new array is equal to array dot as type of int. So print, we are printing the new array. I am just printing the new array. Print on new array dot dtype. What are the dtype? Dtype means data type. So I want to see the data type means I am just printing a int 64. That's the basic condition of this. So what it does, it turns a float type to the integer type. It removes the decimal part, not rounding. It removes the decimal part. Okay, that's a basic condition. So we can able to yeah, these are the things I just want to cover. So I just covered this. So array is equal to, I just creating another array np.array of 1, 2, 3. Inside this I just creating a dtype is equal to float 64. This is giving a float type is equal to float 64. Inside this print array, if I advance if I print like this, if I want to see the output for this, these are things. These are very tactical, right? If you see, you can able to see I just creating a NumPy list here, but I'm just converting this into float 64 array. So I just import it using the integer. I just converting d using the d command d types is equal to float 64 means automatically I'm from 1.2.3 point. That's a basic condition. So that's a basic condition for this. If you are seeing advanced casing, we can able to see the advanced casing, and array is equal to, I'm just giving the np dot array is equal to true comma false comma true. So if I am just converting this as type of int means if I am converting the boolean to integer means it will like looks like this 1 0 1. That's a basic condition. Print of new array means you can able to see 1 comma 0 comma 1. That's a basic condition. String to array also you can able to create. So if we give the array is equal to np dot in the within the double quotes means it's means the strings, right? Np dot array of within double quotes is a string. I am just using a 10 20 string. These are the strings. I'm just converting a new array array dot as type of int. If you give array dot as type of int means you can able to convert 10 20 30. That's the basic condition. Make sure the strings are valid numbers. If not, it will throw an error. That's the basic condition. If you like apple banana means it will be definitely throws an error. Apple is not a number. That's the basic condition. I just want to give the summary. D type means tells you the data type, and as type means change the data type. As type means we are converting the data type from float numbers to the integer number. That's the basic condition. Always make sure the type you are creating makes sense. Make sure what type you are creating. That's a basic condition. That's a basic condition. So I just covered all the things in the session. So please make sure to subscribe to the channel. Now let's get in the next session. In this session, we are going to discuss about the typecasting. So what is mean in the previous session also we are discussing the typecasting, but in this session we are getting advanced into the typecasting. Sorry guys. Now I'm going to getting deeper into the typecasting. So in the previous session, whatever I told, typecasting is equal to changing the type of data. We are converting the float type into the integer type. That's like right. So if you want to again want to explain this thing, I just come with an interesting story. So you have an orange juice. So think of the orange juice in a glass. It's a float. So you want it in a juice box and integer. So but it's a apple. It contains the apple. Right? You want it in a juice box and integer. But if the juice has bulk bad characters, it won't fit right. So float int doesn't fit. So that's the basic condition. So NumPy typecasting. Here recap. So we use, so wait for a minute. Yeah. So we use as type to change the data. In the previous session itself I discussed, use dot as type we can able to change the data. So we are importing the NumPy as np, array is equal to np dot array of 1.1, 2.2, 3.3 and array int is equal to array dot as type of int. So we are converting and the float integers to the integer data type. So we are printing print array int. That's a basic condition. So right, that's a basic condition. So what is the typecasting error? So now we are getting in advanced sessions. When we are working with the errors, we are getting gradually increased with the, gradually learn many of things with the using the NumPy. So that's the basic condition. I just come with them. So what is the typecasting error? Typecasting error happens when NumPy cannot convert a value to one to the new data type. So in J, hey, I do not know do this two into what you asked for. So the common this type errors, right? Example string to int. So if you use a, yeah, as a previous video itself I was told, if you use the apple, banana, cherry, it will doesn't convert it into the integer. So that's a basic condition. Mixed value means if you use a 10, 20, 30, 30 in the strings, if you give as type of integer, it will why 30. 30 is not a valid number, right? That this shows an error. So how we want to prevent the typecasting error means check the data first. So np.array of 10, 20, 30 means you can able to create a no error. We can able to manage the data. So we can able to clean the data, right? We can use the refiltering or replacement. Array is equal to np.array of 10, 20 nan. Within 30 we can able to array nan is not no error, right? So nan means we can able to give it as a np array. We are cleaning np dot var. We are filtering. Now we are nan means non values. Now we are filtering np dot array equal to nan means it's converting. We are converting into 0 and we are returning the array. So this is we are converting here. We introducing another function called the var, and in this it will check var. We in the SQL itself we are checking, right? In the np dot var of array is equal to nan of 0 of array. So we are converting np dot var of array and nan is 0 comma array. That's the basic condition. So print array clean dot as type of int. So that's the basic condition of this course. Alright, we are converting cleaned array. So wherever the nan we are converting into 0, we are filtering and replacement. So that's the basic condition. So we can able to use the try except we discussed in the previous video. It's a previous, I think May of the videos previous. So we are converted. I just explain all this course was what are the try error, except error handling, error giving error as error message. I explain all of the things in the previous and videos itself, previous sessions itself, right? So try print as array dot as type of int. So if we convert, we see array dot array 100, 200, 200. We are giving the strings in the combinations of arrays. So it will throw an error. Try first. We are trying. So if we try, if we give the error, so we have to print the error. So so we are printing casting error e. So we are printing. That's the basic condition. We are the previous videos if I just suggested. So don't check the number, prevent the number typecasting access, clean the data, and use try and error concepts. Right, that's the basic condition. We are recapping that the type error casting error, fix, clean data, cast the error. So that's the basic condition. So now let's get into the next topic is called the NumPy array attributes. So what is meant by the NumPy array attributes? So what are the NumPy array attributes? So what is meant by, first of all we want to know what is meant by the attributes. These attributes are tell how many blocks in the box, how many blocks in the box. So what are the what kind of the shapes in the box and what kind of blocks are inside. It may be the square, it may be the triangle, whatever it may be. Hey, tell me about yourself. That's the basic condition. If the interviewer asks you, right, that's the attribute. You are telling your behavior. The attributes is equal to, in my point of view, attributes is equal to behavior. We are just telling the behavior of things. So when interviewer asks about, hey, tell me about yourself. That's a attribute. We are telling your attribute to the interviewer. That's a basic condition. So how many blocks? What shape is the box? What kind of blocks are inside? So A, tell me about yourself. Let's create an array first. So we are creating the array. First of all, let's create an array. So first of all, let me create an array. So I'm just getting into my Jupyter notebook. I just want to restart my computer, right? So already it mean, yeah, I think maybe taken 50 minutes. I think so. Wait for a few minutes, guys. These are my sessions. So this created this. Okay, the array has been created. So let me create, these are my, what are the attributes, what are your behavior, your name, your studying, what are you studying, what are you pushing your degree, what are your qualifications, what are your skills. That's the attribute, right? Now in the NumPy array, what are the dimensions, what are the shape, what are the size, what are the data type, what are the items used, what are the bytes, what are array that means transpose. Later we have discussed about the transpose. Now for now these are the attributes. So I just want to show, I just created this awesome list. Array.t means nothing with the transpose. Don't worry, bother about that. So if you see the if you give the, if you see n.d means it creates a dimensions, right? Array.dimensions is equal to 2. Shape means it will give the two-dimensional array. So it's a dimension only the two-dimensional array. Shape means how many shape it having 2 rows and 3 columns, right? That's a basic condition. Size means how length of the array. So total how many blocks are inside the box. So that's a 6. Data type is we are using the integer, so it gives a 6. So item size means, yeah, it's a 8. So that's a basic condition. 8 bytes, right? So we are using the 8 bytes. That's a giving the 8. So total bytes we are giving the total n bytes means 48. So how many bytes we are using? 48. So the transpose means we are converting 1, 4, 2, 5, 3, 6. We are converting, transposing the array. So if you print like this, when I have my writing pad, so I just want to explain this code. In the next sessions, I just plan to buy a writing pad. So what do you think about writing a writing pad? Let me know in the comment below. So in the comment, I just want to see 1, 2, 3, 4, 5, 6. We are transposing 1, 4 getting into this line, 2, 5 getting into this line, 3, 6 getting into this line. We are transposing it. That's a basic condition. So we are just planned about these things, right? So array.nd means how many dimensions, how many layers you are having. You are using the 2D layer, 3D layer, whatever it may be. That's a basic condition. Array.shape means what is the shape you are using, 2, 3. So how many array.shape means how many total blocks are you are using. What type of block, whatever it may be. Maybe the integer block, whatever it may be. Item 6 means how big one block in bytes. For integer 64, it may be the 8 blocks. For integer 32, it may be the 4 blocks, right? That's a basic condition. So array.n bytes means total size in the memory. What are the memory? 6 into 8 means 6 into 8 means 48. That's a basic condition. Array.t means transpose. We are transposing it, flip rows or columns, map rows, columns, right? That's a basic condition. So I just explained this code in the Jupyter notebook itself. I just completed this session. So the next topic is that array reshaping. So what is meant by the reshaping? As the name suggesting itself, we are reshaping the array. So imagine you have the Lego blocks. If you do not know about the Lego blocks, wait for a minute. I just want to show the Lego blocks also. So if you do not know about my fellow subscribers are kids, right? I just want to show. So these are the Lego blocks. So I just want to show. See, these are the Lego blocks, right? These are the blocks that can be used to reshape the. That's a build blocks. We can able to build something stuffs, right? So that's the basic condition. So if I go into my Jupyter notebook, so my notepad. So I just want to imagine you have the Lego blocks. Imagine you have the Lego blocks lined up with a single row, whatever may be single row, and you have want to build them into a rectangle 2D and or a cube. Now, what I'm going to tell. So imagine you have a single row. You want to build in them into the 2D array. You want to build in them into the 3D array. What can you do? Reshaping is the only process we can able to converting 1D into the 2D and 2D into the 3D. Reshaping means changing the shape of the array without changing the data. We are changing the shape only, but without changing there is no change in the data. We are changing the shape of the array only. So what are the functions to be used in the reshaping means reshape, ravel, flatten. These are the functions that can be used to reshape the array. So first of all, reshape. What the functions do, how it works, right? First of all, let me know about the baby version of this reshape. So it will be change the shape of the array. So it will be whatever it will do, it will change the shape of the array. So that's the basic definition. Ravel means flattens the array into the 1D array. If we give the 3D array to this Ravel, it will give the 1D array. It will flattens. So many of the people will confuse what means the Ravel and the flatten means flattens into 1D but creates a copy. That's the basic intuition. Flattens array into the 1D array. It will be giving the view. Later we are covering a view versus copy in the later sessions. For now, it will, for viewing purpose only, it will create the array. But the original array is in the 3D array only. For viewing purpose only, it will be creating the 1D array. So now itself I just told you about the view versus copy. What it means view? So imagine you are drawing an elephant in your notepad. Okay, you are drawing an elephant, you are sketching some colors in the elephant, and you are drawing some elements. So you are showing to your friends as a 1D array. So but elephant is a like a elephant only, is a 3D array. But you are showing to a friend, that's a view. But what's meant to copy means we are taking some elements of the copy into some we are taking a xerox. Imagine taking xerox of this elephant. So it looks like similar, right? That's a copy. That's a flatten means flatten into the 1D. It's the basic condition. I just covered all the things in the same session. So I just explained this very clearly. Please make sure to rewind this video if you do not know about something about means. So import NumPy as NP. I'm just using creating the array. So first of all, let me create the array. So the array has been created. I just written back after this some break. So just simply, first of all, I just why my chunk are rolling, I don't know. So I just simply create my array. So first of all, I just simply created my array. The output is just as you look like it's a two-dimensional array. So 1, 2, 3, 4, 5, 6. So first of all, I use the first functions. I just want to use the first move to the aim. So it changed the shape like folding socks into a drawer. Folding socks into a drawer. We are folding. How we can put the socks into the drawer? So we are first of all we want to fold, right. We are folding. We are folding a draw socks into a drawer. If first of all it's a two-dimensional array, I just want to reshape it. Reshaped is equal to array dot reshape of 3, 2. So 3 rows. It's a 3 rows. I just want to think the 3 rows in what how it can we make. NumPy will take care of it. So just simply copy this code. So I just want to print, right. So copy this code. So just simply paste this code. If I paste this code, see how it looks like. It will be changed. So now it's a 3 rows. So yeah, in 3 rows. So I think yeah, 3, 2, right. Yeah, you know it can be changed into 2, 3. Sorry, 3, 2. So whatever it may be. Alright, now it can be changed into 3, 2. It can be it before it will be 2, 3. So clearly I said again 2, 3. 2 rows, 3 columns. Now it will be changed into 3 rows, 2 columns. That's the basic intuition of reshaping. We are reshaping it. So 1, 2, 3, 4. It will be output is that 1, 2, 3, 4, 3, 4, 5, 6. It will be changing. So you must give the shape that matches the total number of elements in this case. In this case, it sticks. So it can be done, doesn't give any error. So if you give mismatches to the total number of the elements, it will be definitely maybe it gives some error. It gives some warning, I think so. So if you want to auto shape, if you want to give the auto shape means you can able to give the auto shape is equal to array dot reshape of -1, 1 print auto shape. That's the basic condition. So Ravel turns any shape into a 1D array. Ravel means it will be showing the view only. It's a view. I just explained this. It's an elephant story, right? So turns any shape into array into the 1D array, but just views the same memory, no copy. That views as the same memory. It will take care of the same memory only. But for view only, it will doesn't take any copy. That's a basic condition. So I just want to show to my subscribers. So if I put this code in this cell, so if I run this code, see whatever may be, it will be changed in the 1D array, but the memory size is the same, but there is no copy. It is only for view only. So that's the basic condition. So flatten means I just explained this code. Flatten means it will be taking the copy. It will be same thing. Similar. It will be flatten this code. 1, 2, 3, 4, 5, 6. It's in the same line. That's the basic condition. So I just want to again recap this code. Reshape means reshape the array. Travel means flattens to the 1D. Flatten means flattens to the 1D. Safe copy. It's a safe copy, right? That's the basic notion. So I just want to give the getting into the next topic called the arithmetic operations. So why we are getting into the NumPy? The basic moving forward is that we are going into the NumPy is that we doing the mathematical operations very fastly. Moving the mathematical operations, we can able to work with the large data. So that's a basic intuition we are getting it from Python list to NumPy, right? So we want to. It's a basic concept. It's a very important concept that we are going to the NumPy. We are moving forward from Python list to NumPy. That's a basic intuition, right? So we are going right. Add, subtract, multiply, divide. We are able to rise above a take square. You can able to get take square roots. We can able to within a single line of the code. We can able to give that. So that's also available in the math model, but we are using in the NumPy. So the NumPy also having certain mathematical operations in it. So we can able to use the np.sq or means we can able to give the square root. So it will be already available in the mathematical model. Yeah, import math means we can able to get the math square root operations. Many of the operations we can able to get. Power of POW of so I think so it will be available in the math model. So I think everything is covered in the Python sessions, right? So if you are the data scientist, data analyst, data engineer, this Python course is for only you only guys. So up to functional programming, for only the software engineers. So after functional programming, it definitely for only the data enthusiast, data analyst, data engineer, data, everything about the data. I just working with the data, right? So I just explain this code with the data. So it will be maybe taking some while, but it will be worth for watching. That's my point. It will be worth for watching. Add, subtract, multiply, divide. We can able to get it. So first of all, so I just want to show two examples of for you. So just creating the simple array. So I just importing this array. So I just importing the array. So I just getting into my Jupyter notebook and place this code in my cell. So I just created a simple array. So it want to show the basic operations, right? So if I copy this code and paste it in my Jupyter notebook, so I just want to add this to array. Print add. If I add this array, if I do it in my non list means 1 2 3 4 5 6. It will be merged it. That's a basic plus operator works in the Python list. But now we are using an NumPy array. It will be adding 1 plus 4, 2 plus 5, 3 plus 6. That's a basic intuition. It will be doing why my interruption. It will be doing some operations of the plus operations, both difference in many of the things, right? Stay hydrated, please. So print, addition, subtraction, multiplication, division, power. I just want to do the same operations. These are mathematical operations. I just explained in the previous itself, right? Addition means if we add means y 7 9. If you do subtract means minus 3 minus 3 minus 3. If you do the multiplication means it will give the 4 10 18. 1 into 4, 2 5 are 10, 3 6 are 18. That's a basic notion. If you divide means 0 0.25, 0 0.4, 0 0.5. So if you do the power means 1 power 4 4. So 2 power 5 means I think yeah 2 power. So that's the basic unit 149. That's the basic unit of it. So these are the things I think I should. So I just want to show to A only. So if you give your power 2 means 1 star to 1. So 2 star to 4, 3 star to 9. That's the basic function. These are the basic operations that we can able to do with that, right? So we can able to multiply with A of 0 plus B of 0. These are the index. We can able to work with the index also. These are the next. I think just plan with the next session. Yeah, I think let's plan with the next session. I just planned many of the sessions, right? So I just can't don't worry about it. I just explain all of things with a very simple and easy manner. So what for watching. So please continue for this video. A of 0 plus B of 0, A of 1 plus B of 1, and so on. We can able to do that. So extra useful NumPy functions are square root. Yeah, this will right. mp.sqrt means we can able to square root, right? So np.exponential of a means we can able to exponential. You can able to use the exponential function. np.sin means we can able to use the sine functions. np.del we can able to use the logarithm also. What shapes it doesn't match? What if doesn't shapes doesn't match means np.array of 1 comma 2 means. So a plus b doesn't error unless the shapes match or can be broadcast. Broadcast means we can able to broadcast means we can able to extend. That's the basic. I just planned in the law. I just planned in last before of second session. That's the basic condition. So C is equal to NP dot array of 1 comma 2. I just want to print A plus C. So A plus means error, unlist, and shapes, and the match that can be broadcast. That's the basic. So if you, the shapes the same match means it will definitely shows an error. So that's the basic condition. Please make sure to note up in this new notebook. So I think I just cover everything. So example array plus scalar. If you print the A plus 10, we can able to print means 1 plus 10, 11, 2 plus 20, 12, 3 plus 10, 13. It will be adding something, right? The basic array advanced example means we can able to get the 1D array. If you add x plus y means multiply, we can able to get the same result. I just explain of this code, add, separate, multiply, divide, power, functions, np dot square root, np dot sin, np dot log, np dot many other things are available. If you want to get something, if you don't want to learn everything, you learn something basics to get an entry into the company. After like getting an entry into the company, you can work with some projects, right? That's for that project you want to learn something. You don't want to learn. Imagine you don't want to learn. If you learn something, everything from your mind, how your brain works. That's a basic condition, right? So you don't want to learn everything. So you know something, you can able to get anything. That's a basic condition. It's a Abdul Kalam quotes also. So imagine giving a universal. Yeah, I just also forgot about it. It's a universal functions. Yeah, there are many universal functions in NumPy arrays. Universal functions are U functions, special NumPy functions that are applied math to every element in your array. That apply every math element to the every element array. So imagine giving every kid is a query in one go. Giving every kid, yeah, giving every subscribers, we can give you the 1,000 rupees means you don't do each one. NumPy does it fast. Begin the scene. Begin the scene. NumPy works fast. I want to give every subscribers to thousands means I definitely give in later. Now I don't have any money, so definitely I give. So if I want to give this thousands to give away to my subscribers, it do NumPy works begin. It's just an example. So why we want to use means super fast. It's a cleaner code, no more loops, and we can able to get it. The universal functions are np dot square roots, exponential, log 10, sine, cos, tangent, so absolute value, floor, seal, round, many other things are available. If these are the things are explained in previous session itself, right? In the basic sessions itself, I just explained np dot square root, np dot exponential, np dot log, np dot log 10, np dot sine, np dot cos, np dot tan, np dot abs, np dot floor, np dot seal, np dot. These are the examples I just if you want to work with the notebook, I just have to give this code in my Jupyter notebook and GitHub repository Kishore22xy. As you know, if you follow these previous sessions, right? If you follow the previous sessions, you can able to get the previous sessions notebooks also. So if you want again this notebook to your personal mails, you can able to ping me a mail in kishorekannan82@gmail.com. Then the email is in the description box at kishorelytics@gmail.com. Whatever maybe I'm the owner of this email, so you can get the notes of this. So I just explain this code with a sign example. Advanced session matrix, we can able to create the square root also. We can able to work with a multi-dimensional matrix also. We can able to square root. That's the basic condition. Broadcast. Yeah. Now we are using the broadcasting with the U functions, right? My drivers are getting failed. If I press backspace, why my drivers are getting failed? So if you don't know, if you know about that, please let me a comment in below. I just worry about that. Do refuse the I just want to get ready for my PC. So broadcasting, how the broadcasting works? I just explain this now. For now, just simply listen my code. Array is equal to np dot array of 1, 2, 3 as printing add 5 as adding of np dot add of array comma. I just want to print the 5. So when 1 plus 5 6, 2 plus 5 7, 3 plus 5 8. That's the basic condition. If you want to print np dot multiply, that's the basic condition. Broadcasting with U functions, you can able to give. So what's meant with the vectorized with loop without NumPy? It may be the slow. So without NumPy, it may be the slow data 1 2 2 3. So if you give the list comprehension square is equal to for x in range of data, it picking one number from data and it will be multiplying by 2. So if you want to do with NumPy, array is equal to np dot square of array. That's a basic definition. A single line of code. If you want to write this like big sentence, this is a simple line of the code, we can able to get it. Yeah. So the recap, it's a next time. So U functions is a mathematics tool for arrays, work with an each element, loops needed, super fast and efficient. Bonus, if you is a check if something is a U function. Check if something is U function. Let me add in the comment below. So now let's get into the next topic is called indexing and slicing. So you know basics of the Python, right? You know basics of the Python very well. As covered this indexing and slicing in my previous video. If you do not know about the indexing and slicing, please make sure to watch that video after come to this video. So now also I'm just explaining what's meant with indexing and slicing in a little bit, and but the deeper version of the indexing and explanation of deeper version of indexing and slicing is available in the previous video. So why it takes much time means because if I take much time of this indexing, explaining things in indexing and slicing means then what are thing what then I missed something concepts or important concepts in one page. So only I'm just telling. So imagine I just giving the array is a row of candy. You can pick one candy or grab the handle. So imagine you have a row of candy. You pick one candy means it's indexing. Indexing. If you grab a handful means it's slicing. That's a basic definition. So I just explained. If you do not know about this means I just explained in the previous video. So please make sure to watch this video. So in NumPy, arrays are like special trays of data. You can choose what you want easily. You can be able to choose very of these things. So for now, let me pick one item. So if you give the let me create the summary np.array of 10, 20, 30, 40, 50. If you give the array of 0 means it will print the 10. If you give the array of 2 means it will give the 10. The index will start from 0, 1, 2, 3, 4. Now I am to remember I just tell the secret formula for counting the indexing in the previous video. Please make sure to watch the video. So index start from 0 like books form itself 0, 1, 2, 3. So see 0, 1, 2, 3, 4. That's the basic initial. So if you can able to use the negative numbers also. Print array of -1 means it gives the 50. Print array of -2 means it gives the 40. So slicing, you can able to take a slice. We are grabbing a handful of chocolates. That's a characterizing. I want one from one index to fourth index means inside the between them. I just want to give the semicolon. If you give the semicolon from one index to fourth index, if you want means I just gave it right. Python just gave. Print array of 1 is to 4 means 20, 30, 40. It starts at index 1 and goes up to but not including index 4 50. You can also skip the start or end. You can able to also skip. You can able to skip the start. You can able to skip the end everything. But and step 2 skip the values, and we can able to skip the script also. So I just want to print array of is to 2 means that is 0 is to from 30, 30, 50. Every second value is from starting to end. There is no limit. From in this the step value is 2. So 10, 30, then 50. That's a basic English. So the 2D array matrix is equal to where is my mouse pointer right? So from the next video, I hope in the next course I just got my writing pen and just explain this code with my handwriting and that will maybe get with enough for you for understanding. Also, I just explaining all of things with quite and a quick, cute manner. For better purpose, for better explanation purpose, I just written if I written this code and my hand means you can able to get it in your own right. So I just planning to buy. So matrix is equal to np.array of 1, 2, 3, 4, 5, 6, 7, 8, 9 np.array. So I'm just creating a 3D list. So grab an item like this. So I want zeroth from zeroth index. I just want to in the first element, second row, first row, second column. See from the zeroth column. These are the zeroth column. These are the zeroth row. These are the first row. These are the so I just want to. These are the first row. Okay, are able to understand the second row? I think this is second row. Zeroth row, first row, second row. So in this zeroth row, this one the first column. So it means from 0, 1, 2, 3. Now the first column means 2. The output is 2. That's the basic condition. If I print the print matrix of 2, 2, the second row I just want the second column that's 8. Second column means 0, 1, 2. 2 means 9. That's the basic condition. 2D slicing also the same. It is also the same. If you want 0 to 2 and 1 to 3 means it will print. Definitely it will print from 0 to 1, not including 2, but columns from columns to 1 to 2, not including 3. it will print the 2 3, it will print the 2 3 5 6. So what I'm going to say, 0 to 2, not it will be 3. So 0 to 2 means it will including 1, I think 2 3. So that's the basic notation. Yeah, you can able to play with numbers also, slicing with the steps in 2D and matrix of is to 2, is to 3. You can able to skip the start, you can able to skip the end also. That's the basic notation of these numbers. So index array of 2, 1 value, slice array of 1 is to 4, range of the items. You can be able to grab the chocolates. And the story, if your interviewers ask about some story, you can able to get some my interesting story. The interviewer asks something questions like indexing, like most of the time, and you can able to get my story in your mind. That's not only you can able to explain all the things what I'm explaining in my YouTube channel. That these are the concepts. Okay. So now let's get into the another topic called the multidimensional slicing. So what is meant by the multidimensional slicing? Slicing it's similar to the slicing, but we are working with many of the multidimensional array. So I just want to cover in this session itself up to this. So I just want to cover this also because it's also cover. I just covered this transpose also. Yeah, it takes for a few minutes to up to this up to transpose of 3D arrays. I just want to cover concentration in the will be in the next session. Okay, so from morning itself I just want to written this with my fingers also, like that, type this code. Okay, don't, please make sure to subscribe to my work. 2D slicing I just covered, right? So now let's get into the multidimensional slicing. If 1D slicing is like cutting a single row of cake. So if 1D slicing is like cutting a single row of cake, multidimensional slicing is like a layered cake. That's a basic definition. 1D slicing means single row of cake. Multidimensional slicing means it's a layer cake with a 2D or 3D array you can able to slice. So entire block of the code start with the 2D array input. We can able to see this created the array, import numpy as np. I'm just using the array 2D is equal to np dot array of 10 20 30 40 50 60 70 80 90. Looks like this. So I just want to show row 0, row 1, row 2. These are row 0, row 1, row 2. I just want to show the slicing index. So I just want to row start. We are working with the multi-dimensional index. Row start, row in, column start, column in. That's the basic condition. That's the basic formula for this. I just created my own formula to explain the use case. Row start, row in, column start is to column in. That's the basic, just like a 1D slicing, but with the rows and columns. So we can able to get the array 2D. 0 is to 2. Row start means 0 to 2. Column start means column start to column in. Grab rows and zeros and 1, column zeros and 1. If we get means 10 0 40 50. This is maybe the output. I just, if you do the, you get only first row means you can able to, if you put this 0 you can able to 10 20 30. Each two means I just covered all of the things in the previous session itself. I just want to create another array 3 is equal to np dot array 1 2 3 4 5 6 7 8 9 10 11 12. This looks like two blocks. It's a cube like. Every block has a 2 rows, each row has a 3 columns. So the shape is 2 is to 2 is to 2 comma 2 comma 3. So every block has 2 rows. See, every block has a 2 rows. 1 2 3 4 5 6 7 8 9 10 11 12. So each row has the 3 columns. 1 2 3 1 2 3 4 5 6 1 2 3. Now the shape is 2 2 comma 3. Okay. Slice the plus block means what's the formula? So what's the formula? Now the formula is that row start is to row in, column start is equal to column in. So if you use this 0 comma, the shape is 0 0 comma, I just want to in the breakdown. 0 means the first block. I just want the first block. So in the first block I just want the entire thing. So I just giving all rows in the block. Is to 2 means the first 2 columns. I just giving the column. Row start, column start. I just want which block you are wanting in the slice. The 3 array you are using with we are including another formula called first block. Which block you are using? We want the slicing index. That's the basic condition. We give use means slice 1 comma 2 4 comma 5. That's the basic condition. So I just cover everything from 1D to 3D array how to slice with the arrays. So that's the basic condition, right? First row means array g is comma 0. First column means is 2 comma 0. We can able to skip that. So middle row means 3D. If you give this means which block you are want, which row in, column in, column start, column in. If you use means it will entire search for entire. So that's the basic condition. So now let's get into the another topic called the iterations. What is meaning by iteration? As we discussed in the looping itself, looping iteration is called looping. So you want to getting each item one by one, like flipping through the pages in your book, continued by toys one by one. That's a basic condition, right? So in NumPy, you can loop through arrays using for loops, just like a regular Python, but a few cool like extra. So we can able to create a few lines of the code. Within the few lines of the code, we can able to iterate through the NumPy array. So that's the basic condition. So for the explaining purpose, I just importing the import NumPy as NP. I just using array is equal to np dot array of so 10, 20, 30, 40 for item in array. So why I'm going fast to explain these things. These are the things are very similar to Python list, Python. So Python indexing, Python slicing, Python. These are things. Python iterations. It will be very similar, right? So I just only I am going getting faster. So when it's when complex topics, I just go slowly. So for item in array, print item. So output 10, 20, 30, 40. You are looping through each value in a row. So you are looping through each value in a row, 1D array. So 2D array iteration means array is equal to np dot array of 1 comma 1 comma 2, 2 comma 3, 3 comma 4. We are creating this array. So for row in array 2D, we are printing the rows. For row in array 2D, we are printing. We can able to create this row also. 1 comma 2, 3 comma 4. Each loop gives you a one row still a NumPy array. It's a NumPy array. We can able to get it, right? This very similar things. The task is that loop. We can able to loop the 1D array. We can able to loop 2D array. We can able to loop each element. We can able to ND iter. Yeah, I just want to explain these things. So if you are using if you want to iterate through array in now NumPy special iterator, we are introducing nd dot nd iter. It's nd iter. We are introducing another function called the nd iter. Please make sure note of it. We can able to get array for item in np dot nd iter of array 2D. We can able to get that. Why it's faster, works on many dimensions, works on any dimension, clean and safe, simple. So we can able to iterate with the advanced session also np dot array of 10, 20, 30, 40. So for index value in np dot nd and nd enumerate function means on getting one by one. So that's the basic condition. Index of printing index of index value 0, 0 comma 0 the value is 10, 0 comma 1 the value is 20. We are in enumeration, we are using the enumeration, we can able to do that. So I just explained the nd array getting index and value. I just using the nd dot enumerate of array. So these are the things I just explained. So now let's get into the another topic called the views and copies. So now I just explained this. I just explained this views and copies in the previous itself, right? Imagine you and your friend coloring in the same notebook. If you are coloring on the element, your friend sees it color too. See the color also. You can able to your friend also. You say sees the same color. That's a view. So that's a copy. So that's a view. Both of you share the same notebook. So now imagine your friend makes a photography on your friend makes a xerox of your coloring notebook. So if you color the elephant in a notebook, your friend copies doesn't change. If it change, this also can change. So that's a copy. It's a separate thing. So view linked to the original. It will change the reflex. If it will be linked into the original, if we change these things, copy linked means also will change. So yeah, I'm changing. Our view is equal to array of 1 to 3. View of 0 is equal to 9, 9,9. Change the view. We are changing the new view, right? So it will be now. It will contains the previous session is I just use tell about the slicing 20, 30. So these are the things from 1 to 2, 20, 30 it will be having. Now the output is original. Original is 10, 10, 99, 30, 40. View contains 999, 30. So the output we are adding v of 0 is equal to 999. So the output will become v of array. We are changing the array also. It will be changed. It will be replicated on the original array. That's why I want to tell with you. So we are linked to the original. If you change the original, the link also will be changed. It will be like if you are using the Ubuntu user, you can evoke the odd link, soft link, right? That's the basic initial. So I just explain all of things in a very simple manner. So why it matters? So copy also. If you give the copy array.copy array 1 is to dot 3 copy, make a real copy. It will take some copy and place here. So it doesn't change the copy. If you change the original, the copy doesn't change. So that's the basic condition I just want to say. So 10, 99, 30, 40, 555, 30. That's the condition. So why it matters means view saves the memories faster and but can change the originally accidentally. We can able to but many of the times we can able to make the mistakes. That's the basic conditions also. Copies are safe, but we can able to use them more memory, but we can able to use them more memory, right? So now let's get into the another topic also. And another topic is called the transpose. So what is meant by the transpose? So I just cover up to this, right? Just cover this. So now what's meant by the transpose? So if you know about the transpose, if you are studying in minutes, I just return back after this. Let's see in the next session. Yes, my PC got low battery. I just returned back after the charging my battery. So now in this session we are discussing about the solidly it will be take 30 to 35 minutes of this session. So please make sure awareness of this it. So in this session we are discussing about the transpose and many of the things we are going to discuss. So and first of all, what is meaning the transpose? Imagine you are looking at table of numbers 1, 2, 3, 4, 5, 6. You are having. Now you are flipping the numbers. Flipping if you know the flipping the coin, right? So 1, comma 4, 2, comma 5, 3, comma 6. So 1, comma 4, 2, comma 5, 3, comma 6. Now you are flipping. This that's called a transpose. If you know, if you study about in 10th and 12th and many 10th, 12th, I just studied, right. I just if you know if you are well aware of transpose. So that's the basic notion. If you want to do the matrix means also we can able to do the transpose, right? In the 10th max also we are studying about the matrix. So we are studying about the transpose. That's the basic notion. Import NumPy as NP. I just want to show array is equal to NP dot array of 1, 2, 3. I'm just using the 2D array. I'm just getting a simple 2D array. So I just want to print original array. So transpose is equal to if you want to transpose array dot t. If you print array dot t means it will be use the transpose array. So it will be looks like this. So original array, if you print the after the transpose array, transpose is equal to 1, 4, 2, 5, 3, 6. The dot t is a shortcut for the transpose in NumPy. In NumPy, it will be using the dot t for shortcut for the NumPy. That's a basic condition. So how it will work with the NumPy? Think of rows as peoples. So name Alex. I just creating another name. I don't want to come with Alex Bob in the previous video itself. I just come with a new name called Alex and Ben. So in this Alex and Ben, the age is 10 and score is 90, and the Ben is age is 11 and he scores 95. So if you make the transpose the age and scores, so name Alex and Ben, it will be transposed, right? That's the basic condition. So we can able to transpose into 3D rows also arrays also, and we can able to create the NP data a range of 22, just reshaping at 2, 3, 4. It means two rows. So it means I just want the two blocks. Inside this I want the 3 rows. I just want the 4 columns in each. So that's the basic notation. So transpose is equal to array dot 3D of transpose of 1, 0, 2. If you give like this means we can able to get it the transpose array. I just want to, so I just copy this code. I just simply enter into my notebook. So if you do like this means 2, 3, 4. The original shape is 2, 3, 4. So if you print the original shape, if I print the original array means it will be printing. So it takes much time. I think it will be take up for 3, 4 millions. So not like that, but it will take some time. So if it print means 3, 2, 4. Now it will be changing the column shape, right? It will be changing the 3 blocks. So each block contains 2 rows. In each 2 rows, 4 columns. That's the basic definition. So let's say I want to tell with you guys. Transpose we can able to 2D array means array dot t. If you want 3D plus array means array dot transpose axis 1, axis 2, axis 3. So what is the flips? We can able to flip rows to columns. That's the basic condition. So in the next topic is the concatenation. So what is meaning the concatenation? Concatenation is about joining the array. Concatenation puts them together. Concatenation, if you want to remember about the concatenation, you want to remember about the together. Concatenation is equal to together. Train 1. I just want to print combine the train 1 to train 2. So I just want to give that train A is equal to 1, 2, 3. So I just want to print that train B is equal to 4, 5, 6. So concatenation puts them together. Result is equal to 1, 2, 3, 4, 5, 6. So these are the examples for this. I just want to input NumPy as NP. A is equal to NP dot array of 1, 2, 3. B is equal to NP dot array of 4, 5, 6. So I just want to result is equal to NP dot concatenate of A, B. So we are concatenated. We are using np dot a concat data of a comma b means I just want it 1 comma 2 comma 3 comma 4 comma 5 comma 6. It will be using the same. So I think I just covered about the concatenation. Now let me cover about the stacking. So stacking is also a very important topic. So let me cover the stacking concepts. So it's very important concepts. So what is stacking? Stacking is the putting arrays on a top of each others or side by side like Lego blocks. So stacking is like a putting arrays on top of each side like block. Like we are building the home means we are able to putting the top of each and the right side block like Lego blocks, right? So vertical stack means we are putting like stacking plates like just like we are starting vertically we are stacking array is equal to we are getting a is equal to np dot array of 1 comma 2 comma 3 b is equal to array np dot array of 4 comma 5 comma 6. So result is equal to np dot p stack of a comma b. So the output looks like this, uh, this like the 1 2 3. So 1 2 3 4 5 6 we are vertically stacked the array. So we are the concatenation and stacking is also similar to original. So we are stacking. So we are stacking. It's similar, but concatenation means we are adding. Stacking means we are merging one by one. That's the basic intuition. Horizontal stack means, oh, if you give the horizontal stack like place block side by side. So that's as you look in the picture I just put in the picture. A is equal to np dot array of 1 2 3 np dot array of 4 5 6. So if you give the np dot h stack, np dot h stack means it will be taking 1 comma 4 2 comma 5 3 comma 6. It will be printing the side box from A, from one from B. So it will be printing the horizontally, it will be printing vertically, it will print means vertical stack. So depth stack means np dot d stack, that one stack many other persons doesn't know about the depth stack, but it will be stacking into the 3D layers like sandwich. If you see the sandwich slide, that's the basic condition. So A is equal to np dot array. We are able to connecting with real world examples. So that's what my teaching style. I want to be able to connect with my real world examples and we want to explain with like you are a baby. So that's only you can able to understand the code and everything is quietly and able to understand everything. So A is equal to np dot array of 1 comma 2 comma 3. So in this I just want to print the B is equal to np dot array of 4 comma 5 comma 6. So in that I just want to print result is equal to np dot d stack of a comma b. So if we print like this means 1 comma 4 2 comma 5 3 comma 6. It is similar to stacking into the like sandwich layers. Same thing to like the R stack. So that's a big, these are the things are available. I just want to tell to you, right? So that's why we are subscribing to my channel. So advanced stacking means np dot stack means np dot I just creating the array np dot array of 1 comma 2 comma 3. I just want to give the A is equal to np dot array of 4 comma 5 comma 6. Stack is equal to np dot stack of I just want to give the stack a comma b comma 2 and stack as columns. And if you give the axis as column means it will be giving, it will take the horizontal stack. So if you give axis equal to 0 means if you don't doesn't give means axis equal to 0. It has a default, it will be take the vertical. So it's a basic condition. So axis 0 is I just told right. Axis is equal to 0 is equal to stack as source. Concatenate gluing the arrays. We are gluing paper sticks. We are gluing the arrays using the, it will merge the arrays. V stack means stack arrays top to top bottom. Horizontal means side by side. Then D stack means stack into 3D. It's a 3D array. It's for only 3D arrays. So the stack means stack with axis control. We can able to control with the axis also. This is stack. So the next topic has covered two topics so far. So what are the two topics? So let's go. We are covering the transpose and we are covering the stacking concatenation. So now let's get into the another topic called the. So far we have covered 1389 7 lines. So remaining I think about I just want to cover 2150 lines. I just right. Um, yeah, I think so. So what is splitting? Splitting just like you cut a pizza. If you see the pizzas, right? Have you ever eaten the pizza? I just don't eat the pizza. I just don't skip the junk foods. You also please skip the junk foods, right? If I want to, I just want to keep the body healthy. So just keeping the junk foods and anything. I just don't eat the oily foods also. So you also, if you see the pizza, you can able to cut the pizza into slices. Splitting means cutting into one array into the smaller pieces. We are cutting into one array into the smaller pieces. If you have like the big array 1 2 3 comma 4 comma 5 comma 6 and you want to split into two slices means, so one if we are putting two slices 1 2 3 and 4 5 6, that's called splitting. That's called splitting, right? NumPy functions np.split. We are splitting the array. So we are splitting array command and now np.split of the syntax is number of array, giving the array, and number of splits we want to it. Number of splits you want to split the array. That's the basic notation. So I just want to show to you import NumPy as np and is using the array is equal to np.array of 1, 2, 3, 4, 5, 6. So inside this I just want to splits is equal to np dot split of is giving this array and is split it into 3. So I'm just wanting 3 arrays. So I'm just giving a 1, 2, 3, 4, 5, 6. The total length must be divided evenly or it will be thrown error. The total length must be divided. If you give the 5 means it will be definitely throws an error. If you give the 3 splits, it will definitely throws an error. That's the basic condition. So here also there is having a vertical split, horizontal split. So I just want to cover this also. So I just creating the array 2D is equal to np dot array of 1, 2, 3, 4, 5, 6. So inside this I just wanted parts is equal to np dot b split of array 2D, 3D. So for part in parts, print of part. So I just want to do iterating through the loop and this printing part of printed part means this want to print 1, 2, 3, 4, 5, 6. So this is the basic initial. So yeah, array will split it, but if you want to see it visually means you want to iterate through the loop. That's why I am using the iteration loop. So that's the basic notation of our split also. These are the same similar things you can able to get it in the previous sessions or search through the internet. So advanced is equal to np.c split. So in the stacking also the D stack, right? We are good. We are depthing. We are depthing inside the array. So that's your basic notation. It lies among the depth. It's a 3D axis, 3D axis. In this session, we are discussing about the NP split, NP array split, NP array split, V split, D split. That's a these are the things I just covered everything. So for I just covered 3 topics. What are the 3 topics of transpose, concatenation, and stacking, and splitting in the NumPy arrays. Now let's get in the fourth topic called the repeat and versus tiles. Repeat versus tiles. So in this step, we what is meaning the repeat and tile? This means repeat. So the goal is that both repeat and tile duplicates array. It will repeat also duplicates array, tile also duplicates array. But they do in a different use cases. That way, but they do in a different use cases. That's the basic definition. NP dot repeat means like repeating each tile. Imagine you having that this toy and this frog toy and panda style. This icon I have been used in the pandas tutorial. If you do not know what's the pandas tutorial, please make sure to watch the pandas tutorial. That's very important for data scientist, data engineer, data analyst. So please make sure to watch the pandas tutorial. You say repeat each tie or 2 times, you get so this like orangutan looks like 2 and frog looks like 2, pandas looks like 2. So if you it means np dot n 1, 1, 2, 2, 3, 3. It means array and each array how many times you want it. So that's the basic definition. So 1, 1, 2, 2, 3, 3. np dot name means like copying the whole type row again and again. So it will be copying entirely one time and will be tiling this rows 2 times. So like it's also drifting, both are splitting, both are confusing. So I just explain this again. So this it will take a copy of this line and explain again it will be printing. So that's the basic condition. So 1, 2, 3 means it will be again printing 1, 2, 3. So not in 1, 1, 2, 2, 3, 3. That's not. It will be printing 1, 2, 1, 2, 3, 1, 2, 3. That's the basic condition. So I'll cover our things, right? So to repeat, so I just covered A is equal to np dot array of 1, 2, 3, 4. A and how many times I just want to repeat 1, 1, 2, 2, 3, 3, 4, 4. If I give np dot axis equal to 0 means it will be repeating it will be repeat rows 1, 2, 1, 2, 3, 4, 3, 4. That's like it will be giving 1, 2, 1, 2, 3, 4, 3, 4. That's like a tile in 2D also. It will be giving the like repeat arrays 2 times in both directions. So see if you give it 1, 2 in 2 direction, with this time also I want, this time again also I just want. So both are similar, but it will have the different cases. I just don't want to confuse. Please make sure to if you have any doubts, please make sure to comment. I'm just happy to share all of them comments in comment below. So let's get into the another topic called aggregations. So what's mean the aggregations? So okay, what is mean the aggregations? So if you know SQL means you know very well about aggregations, right? That's my aggregation. Imagine you have the 258 arrays. So I just want to know how many arrays, which is the biggest, which is the smallest, what is the total, what is the average. I just want to cover, right? So these are the functions that I have been having in the NumPy. These are the many functions. I just covered many functions in this tutorial. Please make sure to note the separate for the functions. Notes for separate functions and separate concepts for functions. Please leave some pages for interval. So if the functions are in one page and the concepts for another page. That's the basic definition. I just read about this method only. So np.sum means we can able to add everything. We can able to get total. So np means average. Np.max means as suggest np.max means maximum thing. Np.min means minimum thing. Np.standard deviation we can able to spread how far the number spread for. Variance means we can spread square. Spread of numbers. Median means middle number. Product means we multiply all the numbers. Right. These are the things I just covered. These are the things again and again I just covered, right. So I don't want to repeat the things. I just want to take time consuming purpose. I just repeat things. I don't want to repeat things. So let's get into the another topic called the conditional. So yeah, these are the advanced sessions. I just explained this slowly. So for now, until up to this, I just explain this with a quick manner because you are knowing these things, right? So if you don't know about the some max, I just explained this in the previous section, in the basic section itself. So I just explained going with fast. Conditional statements I just explained in the previous section itself. I have separate tutorial for condition sections, so please make sure to watch the video. Conditional flag based operation. They helps you to ask questions. Which numbers are bigger than 5? So which are the I just want to be greater num mod to equal to. I just want the even numbers. So I just want the equal numbers equal to 0. That's the basic condition I just want. So you got the numbers true or false and like green or red flags. Imagine you have the some cookies 3, 7, 2, 9. You want to pick any one of them which are big more than 5. So if you have means print array greater than 5. If you just like a normal functions we can able to get. So false, false, true. If you get means we can able to get the number we have which are greater than 5. So greater than, less than, equal to, not equal to, greater than or equal to. We can able to use many things and we can able to use the and also in between the two operations. We can able to check the two conditions and be able to print the results also. Yeah, we can able to get the use the number 2D examples also we can able to get np array of 1 comma 5 comma 9 2 comma 6 comma 10 and we can able to get the array 2D of get 5 greater than 5 which are things greater than 5 this can be proved. So just repeating things we can able to get the result. Conditional we can able to ask the result. A result is equal to array of true comma divided or false. Filter we can able to filter or replace the things. I just explained these things in the previous itself. Filter things and we can able to handle the missing values also in the last sessions. Handling the missing values in the last sessions. Now let's get into the next session called masking. So I'll just come back after the session. So please make sure to subscribe to the video up to until this. I just ran faster because I just explained this in the previous video. If you do not know the things, I just please make sure to watch slowly in the video. Then come to the number. So subscribe to the Kishorelytics channel. So let's get into the next session. Okay, now let's get into another topic called masking and vectorization, broadcasting, dealing with and missing values. At the end of this session, we are successfully completing the NumPy. So now we are hero to the so far we are converting the basic to intermediate sessions. Now we are converting to intermediate to the advanced sessions, right? So we are intermediate in the NumPy. So far we are conducting the Python crash course. So we are converting, so you don't need to pay a single money for me. So it's a very important tutorial for Python. So for data analysis, data enthusiast, data scientist, data machine learning engineer, up to Python and NumPy, I just covered everything. Python, NumPy, Matplotlib, Cbon, functional programming, object programming, Python list, variables, data types, and Flask, Streamlit, everything I just covered. And Git also I just covered for this session. So to practice some codes, how to work with the Git, how to upload some files. I cover everything. If you have any doubts in the sessions, see my Kishorelytics channel. I cover everything about Python. So just cover in the next tutorial you can able to see So remaining topics, I just leave something about topics in the Python. So after this video, the Python crash course has been completed, and you will got the has covered many of the video hours of tutorial about Python. It's a big video of Python crash course. It's a one single video of the Python crash course, and after this plan something called interesting to view something interesting course. So now let's get into the masking. So masking in NumPy means using a condition. It's using a condition you can able to mask, right? So what is meant with the mask? So we are masking something. We are masking some code, right? That's a basic condition to hide. So wait for a few minutes, guys. So I just return back after this session. So wait for a few minutes. I just return two back. Wait 2 minutes. Yes, guys, I just come with another interesting story called this. So, what is meant with the NumPy? Have you ever seen the mask? Right, the mask is something. What are the things I just want to close? That's a mask. We are masking. So, why we are thinking about the mask means we are covering some things. So, I don't that the other person doesn't want to show. See that things. So, we are hiding the things. We are hiding. Pick the one value that you care about from array. It's like saying, show me only the numbers that are even. So this I don't want to show the numbers. I want to say to the number. I show the numbers that are even. So I everything is less than. I just don't care about the less than 10. I just don't care about the students that are greater than 95. I don't care about the students that are marks are greater than 95. So I just don't want to care. So I just want to care the students who are below 30. So that person's only will take care of me. So I just want to care. So that's the basic intuition. That's my ideal. So if I teach to 95% student, they will don't respect us. If we see on the road, they will don't respect to us. They will eat data. Bye bye. So with us, like if you see that 30, if you teach to 30%, 20% students, they will give the respect to us and they will not forget. So how we are putting the efforts. That's our, and in everything. If we, they do tell to another students, that's our put efforts to me, and they will take many of the efforts to put on how to get the marks for me. That's the basic intention. I just want in my plan as to tell a small story. So the basic intention. Hide everything that is less than 10. So the condition where conditions makes marks of true or false. So that's like the 2, 5, 8, 1, 10. You want only balls that are bigger than 5. In the conditional statements that I just told, right? A numpy, give me the only the big balls that are greater than 5. So it will be creating import numpy data array. So wait for minutes. Yeah, it's covering the same questions, right? So mask is equal to I'm just creating a numpy of dot 258 1 comma 10 as it's masking. Mask is equal to array dot 5 greater than 5. They are creating the mask print mask of print false false true true true. Now apply the mask print array of mask. If you give means 8 comma 10. That's a basic condition that we are getting this mask. So what are the mask we are getting? Array we are if we are printing the mark means true or false means only. Based on the condition we are hiding some contents. If it false the condition if it is in the array, if it is true that matches the condition. That makes the condition satisfied. If it is false means that the base the condition doesn't satisfy. That's the basic condition. All in one step. You do not have to store the mask. So you want to create a print array of greater than 5. So that's a we are creating another array that's called 8 comma 10. That's a basic. I don't care about the person there that are greater than 95, right? So that means 8 comma 10. So that's the basic condition. Real life use case means I just want to create that temperature np dot array of 30, 35, 40, 45, 50. Mask when where temperature greater than I just want to don't care greater than 40. So that's only the order days, right? 45, 50. That's the basic condition. So I just cover np dot array of 1, 10, 20, 99 masking to we are using the mask real time use cases. We are using the mask to clean the data. 10, 20, 99 minus 99. The numbers are greater than 99 and I just don't want to clean. Data not equal to 999 means I just want numbers. I just don't want minus 99 numbers. So I'm just using these numbers. 10, 20, 30, 50. Bye bye. Bad values. We are converting. We are cleaning the data. So recap, we are using the mask, a filter of true or values. That's the basic definition. So now let's get into the another topic called the broadcasting. So I just explained this term in the previous session itself. Broadcasting. Broadcasting means lets you map between. So I just first of all let me told some interesting story. Later I will cover this important story. So This one to have here, I just having a small type. So inside this, I just there are three trucks. I just having the three trucks toy. So the as you suggest in the pictures, there are three pictures. So three trucks I just have. So I have only single teddy bear. I just want to put each teddy bear to drive this car in each. That's the basic intuition. They are extending the math, right? They are converting, stretching, or repeating the smaller one automatically so that the shape matches. Yeah, repeating the smaller one automatically. We are repeating the smaller one only. I don't reduce the larger one. I just repeating the smaller one to get the automatic result. So it's like hey, I want to add a small type to every big track. NumPy says okay, I will copy that small type as many as needed. That's the basic intuition. We are importing the NumPy as NP as is using the big is equal to NP dot array of 10, 20, 30 as giving a small is equal to 5. So in this example itself, I just explained in the previous session itself. The result is equal to big plus plus means for 10 plus 5, 15. 20 plus 5, this will be adding like this 10, 5, 5, 5, 5. I am adding again and again. If I have 130. I want to add it to the 3 lorry means how it can be possible? It can be possible 10 plus 5. 130 to one car, another 32. We are small, we are increasing, we are repeating the smaller one. I just don't want to repeat the larger one. So I am repeating the smaller one. That's the basic equation. So broadcasting rules. There are three types of rules. To do the basic rules, these are the important rules. When I was studying, these are the basic, very important rules. So if the shape are equal, if the shape is equal, good to go. If the one shape is one, it will stretch the to a match other. It will one shape is one, it will stretch the match to the others. It will they are not compatible, you will get an error. If the shape is not matched, if they are not compatible, it will get an error. If the shape are equal, you can good to go. If the shape is one, it will stretch. Yeah, if in the previous example, it will shape is one, it will stretch to match others. If they are not compatible, you can get an error. So let's cover this expand session broadcast. So yeah, I just want to explain this example also, right? So see, I just creating the 2D array, two rows and 3 columns, and inside this I just creating another array called 3 rows only. It's a 1D array. I just want to print a plus b. If I print means 1 plus 10, 11, 22, 33, 44, 55, sorry 14, 25, 36. That's the basic initial. We are adding the numbers. We are adding the numbers. So 10 plus 4, 14. So 5 plus 20, 25. 30 plus 6, 36. That's the basic definition. NumPy stretched the things to each road. It will matching the things. It will smart, short, and in repeating the higher things to the larger things. So that's the basic definition. Then added them to the row wise. So when the broadcast fails, I just want to fail the way I want to tell that I fail NumPy can broadcast can fail also, right? I just want to tell that. I just want to store the true false. So I just want print a is equal to np dot array of 1 comma 2 comma 3. I just want print 4 comma 5 comma 6. Here I just created the np dot 1 comma 2. Inside this is not matching. So it will be cause an error. Why it's cause an error? Operands could not be broadcast together. So 2 comma 3, 2 comma 3, 2 comma 3 is not equal. The columns is not equal, right? I just told in the rules itself, right? Broadcasting rules. The shape are equal. Shapes equal only means it will really good go. If the shape is one, it will be stretched. Shape it will not come in, so it will be throws an error. That's the basic condition. So I just explain the broadcasting, shape matching, required from right to left. So works when I just told about the rules, sort of the rules. I just told when the times will be useful. So let's cover all of the things and just remaining there are two topics I just don't think so. So the next topics are called the vectorizations. What's mean with the vectorizations, right? So vectorizations means doing math or all arrays on word ones without using loops. So I don't want to use the loops. I just want to iterate the loops but using the vectorization. It's like saying instead of telling your robot go paint these blocks now this one paint I just told I did using the vectorization. I just tell paint them all at once, paint them all at once. In short, faster, clean, can able to fast, clean, no for loops. We don't use them for loops also. So why we want to use vectorization means we are way faster than the loops. Code is smarter and cleaner. So we can able to use the internal C speed behind the scenes. In NumPy magic, it's a NumPy magic we can able to right. So these examples are I just want to show right. So this shows less time. I think this shows the right time. These are things that this explain this code. I just want to, yeah, I don't want to take much time, but I'll explain this code. If it takes much time means I just don't care about the time. I just want to explain. I just want to give my knowledge to my friends and subscribers. See, it will time takes me 1.000 seconds. I just importing a time and just importing an NumPy as NP and just creating a list of range of 1 lakh numbers. Since it is I squared, start time is equal to time dot time. For I numbers, we using the for loop and using I for I star I. There is some logic. It will take some time. So again, using the literal np.arange of np.time, you think you can able to see this means the numpy will take less time. That's the basic notion. I said till the previous list versus numpy, right? That's the basic notion. So practical vectorization means numpy.array of 1 comma 2 comma 3, it will print the a plus b means 11 22 23. Vectorization means similar thing, we are adding. So that's the basic notion. np.2 2 comma 2 means 4 16 836. That's the basic notion. Advanced means, so weights is equal to 60 72. np dot weights means height star 2. Now it will be multiplied by 2. After it will be divided by 60 1.70. That's the basic notion. These are no loops needed. We are adding numpy. There's a match in one shot. We are adding. We don't want to loop. We don't want anything. We don't want by loop. We are using the numpy vectorization. That's the basic notion. Doing math on old arrays. We are using the math, but we don't want to use the loop. That's the vectorization. No for loops. Just use a plus minus. That's the thing. Pro tip: np.square root. There are many functions like this explained in the previous section itself, right? So the next thing is the very important thing. I just after covering this section, now you are the hero to the numpy. So dealing with the missing values. So what is meaning the missing values? Missing values are nothing but I just explained in the previous video itself with the pandas tutorial. And the pandas tutorial I just explained. Sometimes your data is incomplete, like some forgot to the right number, some sensor to recording something, a value is not applicable like NaN, and NumPy missing values are often represented as NaN. np.nan means number, not a number, as I told, right? You have the numbers. If you have data is equal to like this 10 20 np.nan np.60 means you print data means it is like print like this. If you want to find the missing data means is NaN, is the data having the many missing values. If it is print true means the data having the missing values. That's the basic condition. If you want to remove the missing value means data, if you put the title, the title symbol is behind the escape symbol, escape. So print is NaN of data means it will print the 10 20 30 40 50. Okay, print till symbol np.is NaN of data means I will remove the missing values. Print is NaN of data. I just removing the data, replacing them. If you want to replace with mean means you can able to replace np.nan mean of data means filled with the means where np.enn of data, where the NaN can be replaced with mean means that values can be this 32 values. Yeah, you can able to replace with zeros also. np.var.nan we can able to replace with 0 and return the data. So that's the base 0 field. I just explained these things in the previous instance. That's why I'm again running very fastly. So this explain this. Now as I explained, finding business phones, remove them, replace the things with average field with zeros. I just explained. These are summaries I just covered. So what we are covering 2096 lines. So 2094 lines we have covered. So separately we are now you are hero to the pandas. I just cover everything about the pandas. I just know about the pandas pandas and NumPy. In the previous tutorial, I just tell about the pandas. In this tutorial, we are explaining about the NumPy. I just cover everything about the NumPy. Now you are the hero to the. You don't want to learn everything about the NumPy. These are the required basics. These are not the basics. You are it's like up to advanced. I just covered. So this is Kishore signing up from the Kishorelytics. So in the now let's get into the next. In this we are meeting in the next session, next tutorial. And in the next tutorial, whatever maybe. So this is Kishore signing up from the Kishorelytics. Tata, bye bye.